We continue our series on ADC specifications with gain error. Gain error in an ADC is the error in the slope of the transfer function with the offset error removed. An ideal ADC transfer function has no offset and a slope of 1. An actual ADC output has an offset and a slope that is not equal to 1. To calculate the gain error, we begin by removing the offset. Here we see with a slope that is greater than 1, if there were an infinite number of bits, the ADC output for the maximum input would be greater than the maximum ADC output. This is how we will calculate the gain error. We will take the difference between the maximum ADC output and the output if there were an infinite number of bits. In this case, the error is 2.75 LSB. What impact does this have on your system? In this case, the maximum ADC output will be reached at an input voltage that is less than the maximum ADC input voltage. If we had a slope that was less than 1, we see that the ADC would never reach its maximum ADC output. What are sources of gain error? Gain error can come from the sensor, the device, or temperature drift. What do we recommend? We recommend you check your ADC specifications and be sure that the gain error is sufficient for your system. Include headroom in your system for the ADC input range. Or use an ADC with gain error correction, such as multiplying the ADC value before the output, like some of Microchip's power metering and sigma delta ADCs. In conclusion, we have discussed what gain error is, how it might arise, and ideas to minimize it. Thank you.